Friends, have a nice day. Today we will discuss in detail about analysis of common emitter transistor amplifier. Throughout this lecture, we will discuss about the expressions for first it is current gain AI, second it will be voltage gain AV, third we have to derive expression for input impedance ZI. Next, we have to derive expression for output impedance ZO, and finally, we have to derive expression for power gain AP. Before going in detail about these expressions, come to this circuit. Actually, this circuit we have drawn, it is the hybrid equivalent circuit of common emitter transistor. And in order to use this CE transistor as an amplifier, here we have to connect here one voltage source, it is Vs, we can say it is the input voltage source, and one resistance in its series, it is as a source resistance, it is Rs. And same in case of output, we have to connect one load resistance here at output, and let us indicate it as RL. Here this is current IL flowing through this load resistance. Now in this particular case, as per our last discussions, we have derived these two expressions. One for input voltage, we can say this is input voltage VI equals to VBE, because this voltage, input voltage, it is voltage between base and emitter, voltage between base and emitter. Here emitter is common to input as well as this is common to output. We can make this as a ground signal, ground point. So this input voltage VBE equals to HIE into IB plus HRE into VCE. Let us take this equation A. And next equation we had drawn in last lectures, it was also for IO, output current. So this output current equals to IC. Here this is IC. It is nothing but same IO. So this IC equals to HFE into IB plus HOE into VCE. Name this as equation B. And one more equation that we will need in later. So this is for voltage between collector and emitter. That means this voltage between collector and emitter. So this output voltage VCE equals to this current into resistance. So current is IC, that means output current, and resistance, load resistance, here it is. So one more thing, that the direction of current IC and IL, both these are in opposite direction. That's why we have taken this as a negative sign. So VCE equals to minus IC into RL. Take this as equation C. Now in order to find the current gain, first expression, so it is indicated as AI. So AI, current gain, equals to, it is the ratio of output current to input current. So we can write it input current. Now it can be written as output current, it is IO, upon input current, it is II. Now one more thing, we can write IO, it is nothing but IC. In this case it is IC, output current. So this is nothing but IC, and II, input current, this is nothing but IB. So same thing we can write here, IO means IC upon I input means IB. So take this as equation number 1. Now in next case, see, we have this equation for IC. IC equals to HFE into IB plus HOE into VCE. This is standard equation. So we can write that equation here. IC equals to HFE into IB plus HOE into VCE. Okay, now same equation we can write. We have to use value of VCE from this equation as minus IC into RL. So same equation we can write as HFE into IB. Now take this value of VCE as minus ICRL, so it will be minus HOE into IC into RL. Now here we can see that on this side IC is there and IC is here also. So just transfer this term to left hand side. So we will get, see, IC. Now here it is minus, so that becomes plus HOE into IC into RL equals to, remaining is this HFE into IB. Now from this side we can take IC as common. Here is IC, here is IC. So just taking this IC as common, so in bracket here it remains 1 plus here it remains HOE into RL and equals to right hand side, it is same as HFE into IB. Now here IB we have to transfer to this left side and this bracket to right side. So the equation now becomes IC upon IB. We have transferred this IB to this side equals to, here is this HFE and upon this bracket. So it is 1 plus HOE into RL. Now see, IC upon IB. Actually this IC upon IB, this is nothing but our current gain. So we can write this as a current gain, it is AI. That means we can say that the final equation for current gain AI equals to HFE upon 1 plus HOE into RL. So just this is nothing but our final expression for current gain of common emitter amplifier, and it is given like this. So make this as equation number 2. So let us now, our second equation is for voltage gain. This voltage gain AV, it is defined as the ratio of output voltage to input voltage, and it is written as VO upon VI. Now as per the circuit diagram we have seen, this output voltage VO, this is nothing but VCE, and this input voltage VI is nothing but VBE. Now same equation we can write is VCE is nothing but minus IC into RL, and VBE as it is like that. We have to multiply both terms N and D by IB. So there will be no difference, but the terms we will get the adjustable. So now the same equation we can write here. See here, IC upon IB. So we can write minus IC upon IB into second term we can write IB upon VBE. So this is IB upon VBE, and remaining term is into RL. Now just we can write here the same terms as minus IC upon IB. As per our equation C, it is nothing but AI, that means current gain. The second term IB upon VBE, this is nothing but 1 upon ZI, it is input impedance. And third term RL as it is. So finally we can write this equation as minus AI upon ZI into RL, and this is nothing but the equation, or we can say final equation for voltage gain. So make this as equation number 3. Now next we have to derive expression for power gain. So it is third equation, and we have to write power gain. It is denoted as, gain is denoted by A and power P. So as usual we can write this. Again it is the product of voltage gain and current gain. So we can write this power gain AP equals to, first term we have to write voltage gain, or we can say magnitude of voltage gain into magnitude of current gain. Now this same term we can write here AV, as we have this equation, it is magnitude of minus AI upon ZI into RL. This is value of AV, and into value of AI as it is AI, current gain. And finally we can write this same equation here, AI, so we will get its square, so we can write this as AI square, that means current gain its square into RL upon ZI, and this is nothing but equation for power gain, so it is AP. So we get this next equation, we can say equation for power gain, and it is written as AP equals to AI square into RL upon ZI, and just name it as equation number 4.